Question is typically, why Grayling, Michigan? What's the importance of Grayling, Michigan? We have a huge wood basket up here. We get our raw material typically within a 70-mile radius of Grayling. So we actually get material two ways here in Grayling. We get logs and trucks. Every logger that comes in here has to be a FSC certified logger. When we started, there were 2 in this area. Right now we have over 50. We've done a lot of training and they've all complied. So this is a log deck. So the grappler operators will pick out a load of logs, they will set them on the deck will feed them up into the chipper here, trying to get all the bark off the log. You see the mouth of the chipper there? It gets narrower and narrower as the log proceeds in there. And each one of those rows are a row of teeth that just chipping it up into the particle size we want. So we look at the truck dumps over here. The trucks come in, they go to the guard shack, and then we'll have to tell the guard if they have hardwood or softwood chips. He has to go to the rear of the truck as it's dumping. He has to take a sample out of there because what we are looking for is specific, so we know what we are getting. We know we're purchasing for the woods. So when we make a panel, we'll be able to tell you where it came from, who harvested, so we can go all the way back to the origin of the wood. So depending on what product they bring in, hardwood or softwood chips, it will go down into a bunker. The material will go up into one of these RMA buildings. That's a raw material aging building. Now if you look as we go into Grayling, the length of the conveyors, it's a long, steady incline. That's all designed for our climate. The angle of that belt is such that the material will not fall back. It will all proceed up to the top and then dump in there. So this is where the magic happens. So what we're looking for here is when the material comes up out of the RMA buildings, it starts getting sorted. As we go through this process outside, we'll talk about particle geometry. We'll talk about how the chip is milled down to get to the exact size that we want. We're looking for the exact length of the fiber. So rather than getting stuff from the mills, we are making our own. And we can develop our product based on consistency and proven track record. Okay, so essentially we are standing in the middle of the RMA building. The material comes through the roof and drops down in the center of the building onto an angle, and it goes left or right. It's the same material. So you see the material here. I have 2 screws down here that go into the pile, and it slowly pulls material out. So when it goes through the sorters, that it gets the right particle size. Until the material arrives in the building, it will go through numerous sorting processes, trying to sort out the more granular from the more chips, so we can get it through the flaker building and sort it out into flake silo or sawdust silo. Then you see in the middle, the conveyor going up, that's for our going into our fine silo. So when we looked at the chips in there and we could see the heavier granulated sawdust product, that's going up in the fine silo. So that will go through a sifting process. The far conveyor to the right, that's the flake. That's going to go into our flaker building. So it's going to take this flake and it's going to keep shaving it down, just taking a little part off at a time. We'll actually go in there, it'll be good to see, but it's just looking to get this down, 0.06 millimeter, roughly about 1.5 inch long fiber. And we'll see it, and all it's doing is going in a big wheel, it drops on there and just keeps flaking it off, flaking off, flaking off, just like the name says. Because the question early on was like, what makes your board different than everybody else's? It is all about the particle geometry, and there's a lot of science goes into this. If we go to some of our mills in Central America, they've done a lot of work on this is what the size of the fiber needs to be to go into a piece of particle board. Optimal size, strength, this is how we get the reduced weight. Conveyor's going right up into the dryers. Going down there, over, getting dried material, going up and into the screener building. Now at this point, we're very close to the end of the process outside. What we want to have, or what we have to have, is the right particle size. So in our flakes, or in our face material, we have to have the right size. So this is the last screening process. This is the screener room. So when you look in here, you see up top there, it gets over there and it's shaking and it's putting it through screens. So here's an example of one of the screens. This has got a hole in it, but the material falls through there and it gets screened out. This is the largest continuous press in North America.
This one right here?
This is a former, our press when we go in there is 52.5 meters.
Okay.
The largest continuous press in North America. The material is coming in. The dried material is coming in the building. As the material comes in the building, it's falling down through a dousing system. So it's spraying resin on the product as it falls. Remember, the key is to get every side of that particle, wood particle, covered with resin. Now what we're looking for here is we have our face material, which is the fine material. I'll show you in a minute. And then we have our core, which is the longer, stringier fibers. So we have a bottom face, which you see from my pen mark here, out to the outer edge. That will be the first layer that's getting laid on here, right? And you can see it's got all the finer grain material in it. Why is that important? Because if you have to sand it or if you router it, you want your tightest, finest materials here. Then we look in the middle here. This is a core layer. This is a core layer. It's essentially the same material, but why is it in the two sections? I don't want it to come to the former in one big glob. I want to lay even layers. So I'm laying a thin, even layer, then another thin layer. You see the material coming over there? I'm taking the edges off. I am not wasting material. I'm putting it right back into the beginning of the process again. Then as the board progresses down the belt, you'll get down to the end of it, which we'll talk about in the middle, and of my top face, which again is the finer material, but it's all, you see it's maybe, in this one, an 1/8 of an inch thick. This is what we call the mat. So this is coming out of the former. Now can you see the bottom face and the top face, and you see the core layer? If you look at there, what I point out here, you can see that. That is probably, I'm guessing 5/8 material, and that's probably close to a 4-inch mat right there. It is very pillowy. There's a lot of air in it. So that blue belt has a series of pinholes in it. It gets narrower as the mat processes through there. What I'm doing is pushing the air out of it. So look on this side and see how thick the mat is. Then look at what the thickness of the mat is when it comes out. And you can still see your bottom face, and your top face, and your core layer.
Yep.
Most of this process, the fire system, you see the energy plant there, the press hall right there. Everything we've seen, they're managing it from right there. So if you look at our press here, you see the beige section.
Yep.
Each one of those has a different temperature, pressure ratio. What we're looking to do is take that board and expand it, contract it, expand it, contract it. Why? We want the resin to set up evenly throughout the whole board. So each one of those different sections has a different pressure and a different temperature. Now think about it in this context. All the way from the head of the former, all the way through the end of the press. It is one piece of wood, one solid sheet. This is 52.5 meters, which I think is about 170 feet. But we have all the former back there. So what we have to do is coming out of the press, so the board's hard now, right? It's all been pressed together. We'll see it right here. But it's 170 feet long is the board, and then we have the form. So we have to cut it. So this is the end of the process. You see the board coming out of there. See, it's got a nice sheen to it. It looks good. That's still one long sheet. This is what we call the flying saw. Cutting that master panel into workable size. Now see, it's cutting on an angle, but it never stops and it never binds up. Now just like we've seen at the end of the former, we have our gray con here that's looking at the internal quality of the board. If there are issues, we will hit this diverter gate and the panel will drop down there and go into our board breaker. It will chew the board up, send it in the airlocks out to the beginning of the process. If the board's good, it will go into our cooling wheels. The cooling wheels, just as it sounds, all we're trying to do is getting the temperature of the board down to a workable temperature before it gets stacked. 3 master panels will go in here at a time. They go on that side. After 3 panels get in there, it will move 1 position clockwise. Once it hits this roller deck, it will move 1 position down to the second set of rollers. That noise you hear like thunder, that's 3 boards going to the next section. What 270 master panels can go and the cooling wheels at one time. This process is called Lukey. Lukey is just an automated storage location. So as you've seen, the panels will come in, they'll fall into the stacker, and what I'm looking for is square bundles. Those are actual units that are in our Lukey storage. It's going to go in there until they're ready to be cut. The system knows it needs to come down and pick up this unit. So automatically it's going to come down and pick up this unit. Now, just something to keep in mind, the Lukey, that yes, it's taken away from the production line and it's going to put it in automated storage. So this will go down, put in storage, but if I need to feed the sanding line, this will also feed the sanding line. So this booth is a sanding booth right here, that's a saw booth. Okay. So as each one of these panels individually will get sent into our sander. That's one sanding belt. So we're on 5/8 board, so it should be 0.625. It's going to be slightly under that because we're going to put paper on it, then we'll build it back up to 0.625. The board will go into the north Lukey, get stacked up, and get transferred over to the saw line. So the saw line, I have the ability to take these panels and rip them or cross cut them. So the controller in the saw booth has pulled it out of Lukey, put it through the sanding, and when it gets done, it will be ready to be taken away and moved over to TFL or out to shipping. And we call this our high rack storage system, or the manufacturer's sister plan. It's an automated storage location. I have two of these. This side is all for raw board. It has the capability to feed both lines. And on the opposite side of the other line, I have a paper high rack storage, which is capable of feeding both lines.
We've seen the sanding sequence. The panels are still in 10-foot wide by either 20 or 24-foot wide, whatever the order was calling for. So the saw actually makes 3 cuts. So it trims the edge, cuts it down the middle, and then it's going to trim the back edge. So you'll see the cuts in it here. Okay, here it's ripping it to width. So it actually cuts it in 3, Bill. We took and cut the edge off, 3 cuts. Cut the edge off, cut the middle, cut the edge off again. But basically what's going to happen here now is these machines, this is going to come out, and then here it's actually cross-cutting it. Here you're cutting it to your length. So as it comes out, you've got 2 now, 5x8, 5x10 at this point here. Coming into the book, which is now going to carry on and go into what we call a bin, where you make your stack of boards at this point. So what we're doing here is we're basically taking those books we just saw and putting them into our bundles. Now, from this point, what's happening here is that depending if this is a raw board or if it's going into our TFL lamination site. So if it's raw board, then these bundles are just going to continue down the line. They're going to get strapped up and they're going to get put in the warehouse. That's sold as raw board. If it's for our melamine lines, the board is going to come onto this conveyor here, shuttle across on these rails, and get put into our what's called our raw board storage.
This is thermally fused, so it's fused thermally with the board. There is no stick. You will not remove it from the board. Cannot happen. That's the difference between the paper overlay and what we do. It is a much more robust, ingrained with the board. So the paper goes through a quality check before it gets to us from our manufacturer. It does not look the same going in as it does coming out. That will flatten right out. Yeah, so that plate will come in and get set on the bottom.
Okay.
Okay. In between the plate and the press platen is a press pad. It allows us to do even heat distribution, right? So basically it's a heat blanket. It absorbs the heat from the press, then transfers it to the plate in an even state. That way you don't have hot spots. So that way your gloss is the same here as it is here, or the pressure points are the same. It makes that heat transfer very even. That way you get a good consistent board. Color Brain, that is the bomber system for our automatic grading. So we have 10 plate designs. A Timberline texture, the way that it feels is different than our suede with the same paper. And this, we'll be able to see that. So we have 10 different textures right now. We're in the process of hooking it up for all of our SKUs. That way, for repeatability, I don't just relearn it, I remember it. But then we have an operator that still will be monitoring our automatic systems. We're so automatic here, that's why we have our employees. Besides the mundane tasks of opening paper, closing paper, doing our quality checks, we are verifying our automatic systems are accurately repeating, doing the same thing correctly every time. This board has now been manufactured, measured, tested, brought through the sander, quality checks, brought through the saw, quality checked, come to us, verified again.